Well, hi, good morning. Thanks so much for joining me in my shop on, excuse me, March 26th for a run at this Chevy car radio from 1957. It's in two parts. I've already done one video on this and its brother, an identical, almost identical radio. There's a couple things over the years that I've decided, just a couple. One of them is stay away from jukeboxes, and the other one is stay away from car radios. But here's one on my bench. So I was encouraged very strongly by the owner to do what I could, check these out, see if I can get them working, that kind of thing. And the reason I'm reticent to work on a car radio, it's not one like this. This is a tube car radio. It's a fair size. It's not terribly small. There's space inside it. It's the smaller, more modern radios, compact radios, say from the later 60s and 70s, that really everything is packed tight in them. And my experience with those is really not enjoyable to work on them at all. So this particular radio, I'm not the first person to work on it by any means. This one, you can see something is missing here. This one has had its rectifier tube replaced by a silicon rectifier, regular diode, and it's also had its vibrator replaced by an electronic vibrator. I guess you really shouldn't call it a vibrator at all, but that's what's inside this can. And also it's had capacitors done and stuff like that. So I suspect this thing is going to work. But the challenge for me is how to power it up. How to power it up safely. Now I do have a strong DC power supply I picked up years ago specifically to work on radios like this, because a radio like this can draw a fair bit of power. It's only running on 12 volts, the car voltage. So no voltage means more amperage. This radio is called a Wonderbar radio, and it has this interesting bar here. See, it's interesting. What does that do? This radio will automatically tune to the next station and stop, which is a feature you would think, really, they could do that in these old car radios? Yep. So you might think, well, there has to be a motor in there to drive the mechanism. Nope. It's got some solenoids in it. Solenoids are basically a coil with a plunger in it. When we energize the coil, the plunger gets driven in one direction from the magnetic field. And I'm guessing the two of them are pushing like this, and some mechanism is rocking in between. Somehow this radio, as it does that, detects when it picks up a station and is able to stop on the station. How this works exactly, I don't know. I have a schematic for it I found on the internet. I don't have a service manual as such. The schematic doesn't explain very much, it's just there. There are tubes that have the word trigger written beside them. So I would think maybe that's part of the picture of how this thing works. So, I mean, if it works 100%, if I could somehow power it up and it works 100%, well, that's great. The other radio is not a Wonderbar radio. It's a very similar radio, but it doesn't have this feature. So a little less to it, although it looks pretty similar on the outside. Of course, these have to fit into the dash properly, so they have to be a similar size if you're going to have more than one type of radio for a car. The part on the back here is the amplifier and power supply. It's a final amplifier to drive the speaker. There's the speaker there. Looks like the speaker's been repaired here. It's got a couple of punch holes in it that have been repaired. I would think a car speaker, chances of a car speaker being damaged is pretty high. They're in terrible environments, sitting inside cars. They get baked. This one looks like it was probably sitting, gee, I don't know, with brackets like this. I was going to say it's probably sitting in the dashboard. The dashboard of a car, gets very, very hot. So I think there's a high likelihood the speaker is not in great shape. I did take the top off in the previous video I posted on this. That was a few weeks ago, just to look inside and try to reduce my anxiety about it, and it did reduce my anxiety about it. It looks like it's quite easy to work on. So the problem at hand is how to power it up. I think a really good guess. This is the power in jack. This is the antenna jack, if you like. This cable, I believe, is plugging into this unit. So they're not attached. It's plugging in over here. Probably deriving its power from here. There's the light, which is down in here. It's going to light up the dash, the front of the radio. Now, here's where things get a little tricky. It's got two bared off wires sitting over here, and it's got this guy sitting coming on the back piece here. What to do about that? Of course, this is only, you have to have two sources of power, you know, positive and negative. So this would be the positive, and the negative is going to be just the chassis, maybe right on this. Anywhere onto the chassis. Now, because these things draw a fair bit of current, you can't hook them up with little tiny clip leads. It's going to have to be a fairly substantial piece of wire. Substantial wire means stiff wire. The power supply that I plan on using is just sitting over here in the corner, that thing down at the bottom there. That's good, I think, for 30 amps. It's also current limited and protected. Oddly enough, its minimum output voltage is 6 volts, which was a little bit disappointing for other purposes. It'll certainly produce 12 volts and all the current that's needed to operate the radio. So the obvious thing would be plug the parts together, stick some power in here, hook up the negative to this, see what happens. I'm just left a little anxious. I'm not sure what these are for. Excuse me. Or this guy. It's possible this is meant for another speaker. Might be able to trace that underneath here somehow. If it's for another speaker, maybe in the back seat or something. Excuse me. I'm not really sure what it's doing with this kind of lug on it. Or am I completely wrong? And that lug goes in here, which I highly doubt. Let's just see if it'll do it. Oh boy. It goes in there really nicely. Now I'm really at a quandary. If that's the case, what's this for? So this has a shielded wire. Well, I don't think you'd be running power into the amplifier on shielded wire. Why 1, 2, 3 cords? Why two wires? See how they're done here? They're heavily soldered. The shield is soldered right here onto the chassis. Maybe these are the power wires. Wow, I've gone from thinking I know maybe what's going on to thinking I don't know at all what's going on here. Well, what do you say we take a look at the schematic I found? Perhaps there's somewhere on the internet there's a service manual for this. I couldn't find it. I think you can buy them, but I couldn't find it. Yeah, let's take a look at the schematic I found. See if we can figure out what these are. Yeah. So I found this on a web page that is talking about the Wonderbar radio. So I'm pretty sure this is the right schematic, or very close to the right schematic. There might be a few versions of this radio. For instance, the other one I have in the box down here is a little different. It doesn't have the Wonderbar feature. So just at a glance, that's a little better. Just at a glance, this looks like a fairly typical radio. It has the typical tubes in it. That's not quite so typical. 12BF6. And then it has a push-pull output. As you need a lot of volume in a car because the car is noisy. So it has a pretty strong output here. And this is the rectifier tube, which is missing in this radio and has been replaced by a diode. And here's the vibrator, which has been replaced by an electronic thing. I don't really know for sure what's inside. These electronic vibrators are available on the internet. People are making them. Come back. People are making them specifically for salvaging these old radios. The vibrator itself doesn't have a long life. It's noisy. It hums. I have a few old ones here. I don't even know if they operate. But I think it's a very good fortune that this radio has come with this work already done in it. This tube's of interest over here because it's called the trigger tube. What is going on here, I don't know, but we can see what are either solenoids or relays here. I think they're relays. And this is looks like it might be another relay, and this would be the coil for it. You can imagine that there'd be relays involved in the automatic search feature. Trigger. What would you be triggering? You would be triggering probably the stop. You get the automatic tuning feature to stop. The starting is by pushing the bar. So the operator pushes the bar, and the radio stops the action. I didn't have any sign here. Well, this isn't. Here we are. We got something. To heaters, to fuse block, to light switch. A light switch. Oh, right. It's been sticking in my head that the light on this radio would just be on. You turn the radio on, the light would come on. But in fact, the light on the radio is connected to the car light switch via this wire. I guess that would be the case. And then this is probably the manual on-off switch, probably on the volume control. Yeah, you can hear me turning it there. Okay, so we have something that will light a light, something that will power the radio. Since it's 12 volts coming in from the battery, that's just perfect for these 12 volt tubes that are in here to run the heaters. The heaters are all, they're using the chassis ground symbol. So they're just fed through the metal chassis. Not exactly sure what are they trying to say here. Is that a capacitor? I don't know. Capacitor to the chassis, that's what it kind of looks like. It may be their way of indicating this is where a wire protrudes from the chassis. I don't know about that. Lots of stuff I don't know. We just run through the radio here. Maybe we'll spot something interesting. So here's the antenna. I actually have the car antenna here with me. This is a reluctance-tuned radio. Most car radios are like this. So instead of a capacitor, which I think is a little too big to stick in the radio, they developed a reluctance tuning method. So this slug is sliding inside this coil as you tune the radio. And it's setting up a resonance with, I'm sure, this capacitor here. Look at this symbol here. what does this mean? So I have what looks like a capacitor here and a capacitor here and a shared piece. Does that mean there's capacitors in there with 3 leads coming out of them? Well, there's all kinds of that stuff in here. Okay, when you stand back and look at the schematic, you see there's 2 weights of lines in here. There's a heavy line, these heavy ones here, and then lighter lines that are drawn lightly. So the drawer of the schematic was trying to say something with this. What's he trying to say? So you see the heavy lines are going to the plate, the screen. They're here and here and here and here. So every element in the tube is connected with a heavy line. Here the lines change to light lines. There's a big dashed line here. So I think that's basically separating the radio part from the power supply and output tube part. So there must be a wire in between. Where are you? Here it is. So conceivably, that wire that I joined together with the black connector on it is probably this thing right here. Read the notes. Sometimes the notes give important information. I mean, always they give important information. All voltages measured with a VTVM. No signal. 12 volts at what? 12 volts at signal and 12 volts at illustration 37 amps. Whoa, what are they saying? 37 amps. Tuner stopped. I don't understand what they're saying here. At illus 37 amp, tuner stopped. No idea what they're saying. Oscillator and grid voltage taken was set tuned to 1,000,000. Here we are. This is what I wanted to see. Total A drain. Is this an A and a B here? Total A drain 3.3 amps. Total B drain 67 milliamps. An A and a B. I didn't see an A and a B. Not serviced separately. What would they mean by that? Colors of terminals on service part. Indicates lead from tuner coil assembly. See service parts list for replacements may not appear on some sets. Oh, that's just what I need. Just throw in a little more complication. Other odd things on here is this thing over here. What's all this? This might be a fuse. I don't think there's a fuse in here. The fuse would be in the car fuse panel. And it might be fused as part of a general circuit. It may have more on it than just this radio. 73, 74. Got that symbol there and that symbol there. Not serviced separately. Very puzzling stuff. This thing's full of numbers. 3, 5, 4, 11, 10. Somewhere there's a sheet with these numbers written on it and more information about what these are. I didn't see that. There's a G and a K, an and a J, and an H, and a B, and a D. What's all that? Okay, there must be a sheet. It's probably a service manual with all kinds of information in it that I have not acquired yet. This page actually comes out of a magazine article. Wow. Got this guy. What would this be? Tone, probably tone. Where's the volume control? This is probably the volume control here. You see the output from the volume control is going to the grid of the triode, which is providing a sufficient signal. Hey, look at that. There we are. And there we are. So that's so what is being sent over to this part is a ground. And then there's this. This is picking up the B+. Well, wait a minute. No, yeah? What's it doing? I don't know that it's picking up the B+. Okay, maybe we'll start the power supply and work from there in a moment. The output from here is probably here. It indicates shielded wire anywhere. Oops, I keep clicking my mouse by accident here. Yeah, let's start at the power supply and see where we can get from there. So the output of the power supply. These vibrator-based power supplies have some issues with them that would disappear when you change them to an electronic version. And some critical capacitors that take a beating. Of course, this is not what's in that radio now. Something slightly different is in there. This tube's gone. This guy is changed to something else. There's a diode in here somewhere. It's replacing this tube. It's a gas. This is a gas rectifier. Yeah, OZ4. This is 255 volts here. Here we see the filter capacitors, and we see a fairly large resistor in here. What's a double star? See service parts list for replacement. This is probably a part that failed regularly. This resistor here, I don't know. Why would they just indicate one part? Look at the list. Look at the list for everything. Some hidden information, some hidden intelligence in there. So the output from the power supply is traveling along here. And it's going to be fed to the, whoops, gee, I gotta stop doing that. Fed to the plates. Good thing I don't have a gun in my hand. Holy smokes. Yeah, so here's the plate. 260 volts, that's pretty healthy. Yeah, right off of here. And then the other plate it's this way, up here. High voltage got to get to the rest of the radio. How does it do that? Maybe off here? Ah, there it goes. It also goes to the screen grid. So here it is. Yeah, so it is a high voltage here, which would be here, which is then supplying the plate. It must be making its way. Yikes. Onwards. Like, for instance, where's this plate get its power from? Goes down through the IF transformer. What is that? That must be the slug. That must be the slug symbol. D and A. Maybe these are all adjustment points. Yeah, that's what they are. B, H, they're all adjustment points that be referred to in the alignment information. Okay, got the squares figured out. So we're coming back, getting on this wire. Oh, right there. How did I miss that? So B plus traveling here. Again, they've changed the heaviness of the wire. Not quite getting what they're trying to say here. Sometimes in these schematics, the engineer or the draftsperson will heavy up the signal path, so you can look at the schematic and quickly spot the signal path. If that were the case, then this is going all the way down into here. I don't think that's what the heavy line, it wouldn't be going everywhere under the sun. Okay. So let's see if we can figure out what's going on with this tube here. So we follow the grid of the trigger tube. Okay, just take a guess that something happens on this grid, it says 0 volts, that causes the trigger. Go up here, arrive at this area. You see how the detector tube has 2 diodes. So let's follow this one up here first. Comes down through a 1 meg and another 1 meg. In between, it's down here, and goes up here, sneak through here, and go up to a grid number 3 on the mixer tube. So I believe this is going to be, well, maybe not. Maybe this is just the AVC line. Maybe they separated it to so it's not involved with the audio side of things, because they're doing weird stuff with it. Comes down through, that's 1 meg. I thought it said 22 megs for a minute. 1 meg. We're heading down to this trigger tube. So the trigger tube is picking up a rectified voltage from the output of the IF string. So what happens now? So that voltage becomes more negative as the signal gets stronger. So if you imagine the radio's tuning, encounters a station, the voltage here will go negative. That's going to slow this tube down. The output here, oh my gosh, where's it getting its does that say 25 or 125? 125, whatever it is. Gotta get it from somewhere. I'm a little lost here. Okay, following along this way because it's heading towards the next active element, the grid here. 125 volts on the grid here. Looks like on the cathode, that says 120k there. Didn't really write the voltage here. Okay, follow the plate from here, and it gets involved with these this relay. So let's just go back here. So this goes negative. Current slows down here. What's that mean? Voltage goes up. I better be careful with the terms up and down. I really use plus and minus here. I scored a point for that, for saying that. You have 210 here. Well, it's either turning on or turning off this tube is what we would guess is happening. You would think you don't want a current going through this coil all the time, so maybe. I don't know. I don't know. Okay, so this switch is switching. It's showing, did they say how this is shown? Showing no signal. Voltage is measured, term line, that's about the voltage measurement. And illustration, tuner stopped. So maybe what they're saying is it's not in the mode where it's searching. 37A, so it says there's 37. Is there a 37A in here somewhere? Well, not that I can spot right now. At illustration 37A. Tuner stopped. Oh, I just won again. Tuner stopped. Tuner stopped. You could imagine there's no current in the solenoids. Where are those solenoids? They've got to be these guys, don't they? Does the radio tune back and forth to get to one end and then come back the other way? Like, for instance, if there's no stations to be picked up, maybe you're out in the middle of northern Ontario and during the day there's no AM stations. If you push that bar, it's going to search the length. It's either going to reach the end and stop. Where's it going to search from? From where you've got it dialed in to start, or does it? What's it do? Does it go one way one time and the other way the next? Lots of questions here about how this works. Not many answers yet. See, this switch is connected to this. I have to stare at that for a long time to really sort it out. Generally speaking, it would look like this tube is activated from a signal being picked up. This tube is then causing this tube to do something different, which is causing all this stuff to do something different. 106, 107. I gotta get better information on this radio. Now, involved with it is this weird thing over here. So they're shown in a curve. And they have this not serviced separately. So maybe what they're trying to say is that this is a thing, not a bunch of things. Once again, I'm doing really well. So what's the deal about it? What's the use of this part out here? It's going nowhere. Got 130. It looks like 135 volts written down here. Where's that coming from? I'm pretty good at coming up with the questions. Not so good at picking up answers, but this is par for the course. When you're looking at something you're not familiar with, it just raises lots and lots of questions. This is interesting. There's 3 asterisks here. What does that mean? May not appear on some sets. Okay, not a big deal. Okay, so the matter at hand, though, is how to power this thing up. Now, where's the incoming power? It must be right here. Diffuse block to light switch. Yeah, come on in, Peanut. Save me. Save me from all this. I think I'm going to stop, have a break with my cat. That'll make him happy. And I can rest my neck a little bit. My neck got stiff staring at that schematic. Where are you, cat? Where are you? Hey, stop looking at my feet. He looks at my feet to judge where it is I'm heading. Hey, up here. Peanut. Peanut. Oh, man. Okay. I know he's not going to stop meowing at me, so... Okay, a little break time, and then we're going to get right to the point of where to stick the power into this thing, and we're going to resolve that. And we're going to try powering it up. Come on, Peanut, let's go. Buddy. Yeah. Okay, cat time is over. So, let's see if I can sort this out now. So we have this cable over here. It's obvious where this goes. How am I going to do this? Unfortunately, the weather today has turned a little bit. It's gotten colder again. It's just right around the freezing mark. And snow is in the forecast. So now we've ended up with this and this over here, and they appear to go together. They really, really do. If that's the case, I have to guess this is the positive feed into here, and you'd kind of guess, I would guess, that one of these two wires over here, ooh, it's getting a little wide, these two wires over here, one of these is going to be connected essentially directly to here with 12 volts on it, and the other one is going to be, I was going to say the negative side, but there's really no reason for a negative side. This thing's going to be bolted in the car, and that's where it's going to get its negative side from. So it's still a bit of a mystery over here, but maybe if I get my ohm meter out and just check the resistance between these wires and over there, maybe I'll find something out. So in just a few days from now, I'm going to receive in the mail an Allen meter to replace this guy, which is becoming worn out. This one, the switch is becoming worn out. Okay, so we'll put this on low, 200 ohms. Yeah, I can't wait till the Allen meter comes. Okay. We'll separate this again. Oh yeah, it really likes being in there. Oh my gosh. Okay, maybe we don't have to separate it. Stick one lead in there. Wow, plugged right in. We'll see if one of these two wires doesn't show 0 ohms. Well, that looks like 0. And what's the other one do? Nothing. So you gotta guess. Still a guess that this is the positive feed in. Let's check this one to see if it goes to ground here. So put one on the case and we'll go here. No. Let's turn this. It is on. It is on. It is switched on. What happens if we switch it off and we repeat this? It went in nicely the first time. So I was just lucky. Okay, stay there. Let's check. That sure, that kind of proves it, doesn't it? So this is going to be the 12 volt positive one. Now what are the chances this is just going to the light here? So this would be the this would go to the light on off switch. Well, we can read it through the light bulb if that's the case, assuming the light bulb's good. An assumption. Let's find out. Light bulb is good. Put it back in. It's only going to add a few ohms to the reading, so. Come on now. switch it off. If it's the light, it would not be on, and we would see open circuit. Switch it like that. Let's put this up. 20K. Are you the light? Hey, whoop, don't jump around now. Let's get off this thing too. Bingo. Okay, I think we got it sorted out. I think we know what's up. Every wire is making sense. So we put the 12 volts positive onto here, put the ground lead onto the chassis anywhere good. If we want to power the light, we would worry about this, but if we don't want to power the light, we won't worry about it. I think I'll just ignore it. So 12 volts to here from my power supply over there. Prepared some kind, I gotta prepare some kind of wire that's gonna do this and sustain a 3 amp feed, and then pushing this button, no doubt it's gonna go way up. So I would think lamp cord would probably be fine, and I could probably just use a one of those twist connectors, like your house is put together with. Probably going to be okay. Yeah. Okay, I'm going to get that set up. We're gonna try powering this guy up. Okay, so I picked some lamp cord here. This one even comes with a little switch on it. It has rating numbers on it. 3 amps. 6 amps at 125 volts, 3 amps at 250 volts. And I think really what it's talking about is its ability to break that current if you operate the switch. So we're not expecting much more than 3 amps. I'll try and kind of just put the switch on. Okay, I'll try and do that. Too much stuff on my bench here. So we'll put the ribbed part on the positive. Down. It's not absolutely clear which side is switched. We're pretty sure the wire doesn't get reversed, but that doesn't mean it doesn't get reversed. But I think the positive will be the same ribbed side. We'll test this with a voltmeter, of course. I'm going to have to make these a little bigger. Voltmeter right here. Okay, so this is the ribbed one here. Thinking ribbed is positive. Let's put the power on that. So that's putting out about 6 volts. Can you hear the cooling fan that's running in there already? I think this is positive. Don't know about the switch position. There we are. 6 volts. 6 volts with a fair bit of power, current potential behind it. So Don't want to short these. Switch that off. Now this thing has an overload indicator. It's going to go beep 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 as it dies out of after I turn it off. So not to jump when it does it. So we got positive here. I need one of those twist things. Well, I'm gonna have to stop and go out to my garage and get one. Where's the chirpy sound? We're just waiting. In the meantime, while I was taking my little break there, I was watching a video of a pianist named Glenn Gould. Glenn Gould is a Canadian, there it goes, is a Canadian concert type pianist that many, I'm not into piano or anything like that, many would claim that he was the greatest pianist ever. So I was watching this video of him playing. By the way, Glenn Gould had a summer home just a few kilometers from here. There's a sign along the road that says something about Glenn Gould. Watching him play, and he's playing one of those classic pieces, and he's not the only one in the world who can play this stuff. There's lots of highly skilled pianists who can play this stuff, and the thing that amazes me about it, he's playing this long piece of complicated music. There's got to be 100,000 notes that he's playing, and how people can remember all that, it really, I'm in awe of stuff like that. Now, I have trouble remembering what day it is. Glenn Gould. Yeah, I want you to grab a video and just watch a little bit of this guy. Okay, gotta go out and get a connector. If you're at all like me, you've collected your own hardware store stuff. So I got a bigger and a smaller one. Let's try the smaller one. This is the positive. And of course the supply is turned off. There we go. Now we just got to connect this to any handy spot under a screw. Right there where we can see it. That would be a good idea. First we need to find out the position of this switch. So this is off. We know from the earlier test off is off. I'm going to pop on the supply at 6 volts here. We're going to see if we've got 6 volts here. 6 volts. We just have to look up a little higher to see it. 6 volts. Okay, I'm going to dial this up to 12 and check it, but when I turn the set on it may draw down. There may be a voltage drop on this cable. What else do we need to be sure of or careful about aside from everything? Well, I could ramp the voltage up slower. What if there's a short in here? Why would I even be concerned about that? So my power supply is protected, has a current meter on it that I can keep an eye on. Let's see if you can keep an eye on it too here. It's a little hard to get all this in the shot. Yeah, it's a little far away. This is the current, and that's the voltage over there. Okay, so we'll dial up 12 on here. Got up to 12. I could hear a relay clicking there and the fan went faster. But there's no current. Okay. Let's check and see if there's 12 here now. Where's that Allen meter? I need the Allen meter. One of the annoying things about this meter is it times out no matter what, even if you're in the middle of using it. Other way around, Jim. So we're just under 12, which is fine by me. Like 0.01 under. Let's check the switch. I'm going to turn it off. Or switch it. Let's see if that really worked. So we know what we got there. Yeah. Okay, we'll switch it back on. Now, for the moment of truth here. I'm not turning it on just yet. I'll tip this up so we can see it. Now there's no light that's going to come on. What's going to come on that we can see? These tubes will light up. The power supply should be pretty instantaneous because it's a silicon diode now. So I think it's going to be there right away. But the tubes are going to take some time to warm up. So what we should be looking at, I just went and moved the camera. That's stupid. Put it back. Put it backwards. I'm going to keep an eye on that current meter. I'm expecting 3 amps. 3 amps on that meter isn't up very high at all, just up in this range. If it's straight up or more, it's way over. So maybe that's what I'll keep my eye on the moment I turn it on. What happens to the current? Could ramp the voltage up. Why don't we do that? I feel a little better. Okay, we're gonna undo the voltage there. Back to 6. What do we get? Here we go. Okay. Went up, went down again. That's pretty good. Let's put it up to 12. Okay. You can see this is heating. Turn some volume on. Okay, so this whine that we hear is almost certainly that power supply. That's not good. Okay, but we can see the kind of current it's drawing. It's drawing 2 amps. Yeah, that's crummy. I have not made much use of this power supply. Now I could filter it by sticking a big capacitor on it. Let's keep this running for a little bit. I have no antenna. I did not put the antenna on it. I did not put on the antenna. Okay, so leave it running. Here's the antenna. How am I going to do this now? So, I want it extended. This is awkward. The antenna is going in over here. This stiff wire. Okay, we gotta stop. Must stop. I like to kind of clamp this thing up here. I got the body trim and everything with it. Put it up here. Watch out! I just whacked the. So the microphone you're listening to me through is just up here in the sky. I just whacked it with the antenna. In case you're wondering what happened there. Could just kind of lean this up against stuff. I just knocked the camera on the floor. Well, having this big antenna is not the best thing. Lean it up against these grounded pieces of stuff. So this is all good. It's up against some non-conductive stuff. And the cable. We want to stick it in there. How am I going to do that? Got to get it around under here. I'll stick it in. Okay, I don't know. Picking up AM radio with a whip antenna in my shop. Doesn't sound like a very likely thing. Switch this off again. Everything's okay. Power this back up. Okay, this time with an antenna. There we go. Back around 2 amp, about 1 amp right now. Tubes are heating. Okay, ignoring the buzz. How come the buzz didn't come right away? That's a little odd. Maybe it's not the power supply. See what we can get. Right in here. Yeah, it's picking up stuff. I mean, I recognize all those strange sounds. I dare say it works. It's just going to have a heck of a time picking stuff up. Loads of volume. Okay, let's shut her off. What I want to do is look at the kind of voltage that's coming out of this generator and power supply and see if it's really the cause of the buzz. It sounds like there's a vibrator in there, but there's no vibrator. Okay, so all I've done is extended some leads from the power supply over to the scope input here. Got the scope on AC because we're going to look for a ripple or a buzz or something like that. And I just wouldn't expect that power supply to be putting out 1 or 2 amps and somehow not be nice and clean, but let's find out what happens. I've got this on 5 volts per division, so it's going to jump about that much, I think, in the upwards direction, and we'll see what it looks like. So first, with the radio off, switch that back on. I don't want to be in front of the camera when I do it. And you can tell when the supply is running because you can hear it, unless you're going to hear the click. Let's flip this to DC. It's got to be on DC. And what am I doing having it on AC? So let's just make sure. So set it on ground, and we'll move this line, let's say here. Okay, so we're going to go 5 volts. Just above the center line is where it should end up. Just above the center line is where it ended up. Good. And it's smooth and steady. Got it on a pretty slow speed here. Okay, we'll turn on the radio here. The radio is on. And that's as smooth as can be. So what we'll do now is we'll make this more sensitive. We'll get a closer and closer look at it. Bring it down. More sensitive, bring it down. More sensitive yet. Bring it down. I can't bring it down. If there was a substantial ripple there, we could do this on AC. Put it back in the middle. Make it more sensitive. Well, it's not doing well on the camera. There's definitely some fuzz in here. And I think there's something like this going on. Let's make it more intense. Yeah. Okay, I'm going to stop and put a camera on that so we can see it more clearly. I think that's what we're hearing. Okay, you can see the camera in front there. This is what you see through it. Now, quite clearly, you can see these spikes. That's almost certainly what we're hearing. Well, why would that be there? The power supply doing that? You know, I have a brand new charged car battery. I think I'm going to bring that in here. We're going to try this with a car battery. Danger, danger. Yeah, a little dangerous working with a car battery, but I'm going to bring it in. We'll try with that. Okay, I'm very uncomfortable working with a car battery because I know the kind of power these things can deliver is enormous. Let's check its voltage output. Can't afford to make any mistakes. I have the wire hooked up, but I've used this handy switch. So there's no power reaching the radio no matter what. And we want to check, this is the negative, this is the positive, this is the ribbed wire, this is the non-ribbed wire. Okay, now how did I get this? Why have I got a brand new battery? Ah, there it is. 12.6 would be ideal. Went to Walmart, buy some groceries. This is a couple months ago. Actually, I was picking up groceries. We'd ordered them over the internet, so I'm behind the store where you pick up groceries, and I'm just sitting in my car waiting for 10 minutes. A snowstorm going, it's cold, all that kind of stuff, and listening to the radio in my car. And find groceries come out, to go in the car, everything's great. I jump in, I turn the key. There's nothing left in the battery. I realized, oh my God, that's true. The battery's been getting weak, and I've known about it. And just listening to the radio, and I guess a few other accessories running, I killed the battery. What am I going to do? So I phone into Walmart. Do you guys have by any chance a parking lot service where you'll jump? No, we don't. But we'll give you the name of a couple of tow trucks. Oh, no thanks. Sat in my car and thought for a minute, hey, wait a minute. I'm at Walmart. I'll just go in and buy a battery. I got to get a new battery anyway. So I go in, and of course they don't have the right battery. So I decided, you know what, I have uses for a battery, and I never thought about this actually, but I have other uses for a spare battery, so I bought the cheapest battery I could buy there, brought it out. Luckily I had my car jumper cords, jumped my car, get it going, and presto. So it has a new battery in it now, of course, and I've got this one. Okay, so we're ready to fire this guy up off the battery, which I'm sure has got lots of charge in it. I still have the scope hooked up. I can't imagine that's going to be I do not have the scope hooked up. The scope is not hooked up. Okay, so we're going to apply the power, but the switch is off. That's an exciting moment. We're now going to apply battery power. I can hear something buzzing over here. Tell me that's still a vibrator in there. Oh my gosh. Well, that sounds like a vibrator. Now, is that coming out of the speaker? Oh yeah. Well, that's pretty crappy. So, well, that's unexpected, but it kind of tells me that let's put the scope on here and see if what I saw in the scope is really kind of coming back from the radio, not coming out of my big whopping power supply over there. I'd like to know that. Okay, just calm down a little bit. Maybe the scope lead will make it all the way here. Let's take a look. It's funny, I'm not nervous with the high voltage, I'm nervous with the high power. Not exactly. It's a little problematic here too. Well, it's just a scope, so I can just use a regular little clip lead. Anybody who's ever shorted one of these by accident knows why I'm nervous in here. I mean, if you short this wire, like I put a short on over here, this wire will produce smoke within seconds. And okay, so this has a clip. And they run a clip on there. I get a little piece of the wire. Oh my gosh, I didn't have that on there. Very good. Okay, too many things in the hand. At the same time, let's put this back under. Oh! I thought I was tightening it on the wire, and I guess I wasn't. And there must be a shape in here. Is this one's loose too? No. A little more wire sticking out here, so let me do this. If I just get to the point where I have the radio working, you know, so I can assess it, which I think I'm right there now, that's good. But I'm really surprised at the noise it's making. Okay, that's got it. We're going to put on, so we'll put the negative over here, or the ground, or common, whatever you want to call it. We'll put this clip lead here. That hang there. The thing about these batteries, they're always on. There's no turning it off, and then I can clip here. Let's just watch what the scope does. Right now it's picking up a hum from the way things are. Look at this amazing feature. Isn't that amazing? Wow. Okay. We'll put this on here. So that should, we have it on AC. We'll put it on DC. Didn't I have it? I thought I had it 0 down below. No, I turned it up when I switched it to AC, so we're going to put it back down. I think it was here. We're still on 5 volts? No, we're not. We're on, yeah. 5 volts, so it should pop up to just above the center line when I make this connection right here. It didn't pop it. Oh, because I still have it on ground. Here we go. There we are. The voltage is there. So what we're finding out is that weird stuff coming that I saw on the scope coming back from the. What a nice feature. This is a paint stick. Fantastic. You'll gaze upon the scope. And I think I have the cord switch off. I'll turn it on. And now turn on the radio. Okay, I have the cord switch off. Radio off. Cord switch on. There we go. Yep, tube's lighting. Where's that sound? There it comes. It came on slow. Well, that's probably because some of what we're hearing, or most of what we're hearing, is coming out of the speaker. Well, I don't see the same effect up here. I'll just brighten up my scope a little bit. No, I don't see it. Okay, well that's just going to remain a curiosity of what's going on with that power supply. But the real curiosity is what's going on with this radio. Why is it making this noise? It sounds exactly like a vibrator. So it does have a power supply. Inside this can should be electronic components somehow producing a, probably not sinusoidal wave, but some kind of AC. And then it's going into the filter system of the radio, just like it always did. And maybe the filter system is not doing the trick. So we're really hearing basically car radio's version of power supply hum. You commonly hear in old radios. The frequency is not 60, it's much higher. That's why the tone is higher. Would this be acceptable in a car? The fact is, if you're driving down the road, there's so much noise in the car, this may not be an annoyance. But here in the shop, it's really glaring. Okay, so I think at this point, switch off, and then we're going to make this safe right away by removing stuff from it. I'm not going to leave my shop with a car battery hooked up like this. I have cats. Well, I never see them on top of my bench unless I'm in here. This could easily start a fire. Okay, there we are. We're safe now. It says ever start a fire? Yeah. I think that's enough for today. I figured it out, you know, how to power it up, make it operate, and that kind of stuff. Ooh, I never pushed this button. We gotta push this button. Now, should I have it on a car battery which can deliver 50,000 amps into this radio? Or should I put it back on the power supply to do that? I'm going to go back on the power supply because I'm so scared of this car battery. Take it out of here. Scary, scary car battery. That's for my someday solar panel system. Yeah, someday. So we want to reconnect the power supply wires. I'm going to stop the camera while I get this set up again because it's going to be kind of a repeat. Yeah, pushing that bar is the most exciting thing about this radio. I'm going to give you a close-up on the favorite radio as best I can. Let's prop it up a little higher. So you can see where the pointer is. Now, if it actually works, it's going to stop at some noise signal or something like that, I imagine. So we have 12 volts ready from the power supply. Power supply has its limits. Oh, I never noticed that. It says right on the front, output DC 6 to 15 volts. Okay, here we go. Okay, 2 amps, a little under, around 1 amp. That's good. It's doing the same thing again. Tune's lighting up. Don't hear that sound at all. It comes late in the game. Maybe it's all coming out of the speaker. I think that's probably what's happening. It's actually kind of a good sign in a way. Not volume sensitive. Okay, so you can watch the pointer. I'm going to watch that ammeter when I push this. Ah! Knock the radio down. Okay. Did I bump the volume? Is that why it got louder? This is a terrible arrangement here. That's the grounding of this cable. Careful what you're doing there, Jim. Prop it up with one piece of wood. Okay. Anything happened there? Hey, the noise went away. No, what am I saying? The noise went away. The buzz is still there. It did tune somewhere. Let's try it again. Okay, I'm watching that ammeter, right? I didn't watch it close enough. We're at around 2 amps. It's not going up at all. So there's no big current draw. Did the pointer move? Now I'm going to watch the pointer with you. Oh yeah. It's just moving the tiniest amount. It's quiet here. Let's see what it does. Just jump the touch, but there's a signal here. I should pull the antenna out maybe, because there's noise all the way across. Don't like that song. How about this one? It's just not going any distance, is it? You're not supposed to hold it, are you? I can't imagine that. Maybe you do. Well, it's traveling. It seems to stop as soon as I let go of the bar. What happens when it gets to the end? Wow! Holy smokes! Man, I'd take your fingers off if you had your fingers in there. It's back here now. That's a solenoid action. It's got to be automatic. It's not just push this button and stop when you get to a station. Would it be? Unless it's quiet while it's moving. Okay, I'm going to pull the antenna off. Try to fool the radio into thinking there's no stations, because the noise is such that this thing's going to get a voltage out of the detector almost all the time. Okay, so we're going to pull this out. Come on out of there. Okay, it's gone quiet. Can you find a station now? It really sounds like a motor running, doesn't it? I wonder if it's a motor that drives it across and then the solenoid shoots it back. Hey, I'm going to watch the ammeter on the solenoid snapback. Oh, there was a jump up there. Only lasted a moment. Well, that's interesting. Not sure how it's supposed to work. I would think you push that thing and it searches for the station and stops when it gets there. Otherwise, it's kind of a stupid thing. Okay, sound off. Power off. Okay, there we are. That's an interesting journey through getting this radio ready for work. Sounds to me like it needs some capacitors here and there to get rid of that buzz, as soon as we can figure out where the buzz is coming from. I'm going to guess this is full of electronics. Anything get warm during that affair? This got a little warm. Just a little warm. This got a little warm, but it's got these two tubes heating it. Nothing serious. I mean, there's only a couple amps coming over and they're busy doing stuff. They don't have time to heat anything up. Very good. Now, yeah, next up is try to resolve the buzz, figure out how this bar is supposed to work, and go from there. Thanks a lot for watching, and I'll carry on with this radio for a couple of days. I've been working on some Nordmendy radios, and I'm waiting now for tubes to come so I can continue on with those radios. Great. Thanks a lot for watching.